Hi guys, in this video we'll look at combining fractions, partial fractions, examples, and then we'll finish with a summary.
So how can we use some techniques of combining fractions to split fractions? We have seen that we can cross-multiply in order to combine fractions. Take the fraction 1 over 3 plus 1 over 4. When we cross-multiply, we get 1 multiplied by 4 plus 3 multiplied by 1. All of this is divided by 3 multiplied by 4. When all is said and done, this is 7 over 12. We can also use this to simplify fractions with algebraic expressions. Consider 2 over x plus 3 plus 4 over x minus 1. We can use the same method of cross multiplication and we get this is equal to 2 lots of x minus 1 plus 4 lots of x plus 3. And all of this is divided by x plus 3 multiplied by x minus 1. If we simplify the top, in terms of x's we get a 2x and a 4x, which of course is 6x. And the constants are minus 2 plus 12, so this is a plus 10. And we've still got it all divided by x plus 3 multiplied by x minus 1. We'd like to be able to reverse this process to split a fraction. Let's say we had 2x minus 3 divided by x multiplied by x plus 1. We would like to use some kind of method to split this into this following fraction. Again, the method that we'll use here is currently unclear, but hopefully we will develop this method in this video. So what exactly is the method of partial fractions? We can use the process of partial fractions to decompose certain types of fractions. Again, let's say we had a fraction x plus 3 divided by x minus 1 multiplied by x plus 2. We can use the method of partial fractions. This will become 2 over x minus 1 minus 1 over x plus 2. Often we need to factorise, if possible, before progressing further. So if we had 2x plus 11 divided by x squared minus 3x minus 10, we often factorise the denominator and this will become 2x plus 11 divided by, in this case, x plus 2 multiplied by x minus 5. We then make an educated guess of the form of the decomposition. So in this case we're dealing with this 2x plus 11 divided by x plus 2 multiplied by x minus 5. What we're going to do is to guess the form of the decomposition. We're going to guess that it has the form a divided by the first factor on the denominator and then plus b divided by the second factor on the denominator. Next we multiply up to remove the fraction. The left hand side becomes 2x plus 11, the right hand side becomes a, and then we get the x minus 5 plus b, and then we have the x plus 2. Now the equation needs to hold for all x, so we can substitute suitable values to obtain the unknowns. We choose the suitable values as follows. If we choose to substitute in x equals 5, then what will happen in the above is that it will cancel out this entire term here, and we will get an equation purely involving b. Therefore we have 2 lots of 5 and then plus 11, and this equals, well, 0, that's the cancelled out term, plus b lots of x plus 2. Well, that is precisely 7. Therefore we have 7b the right hand side comes over to the left hand side, and then the left hand side is 11 plus the 10, which is 21, and when we divide we get b equals 3. Our next suitable value is x equals minus 2. The reason why we substitute in x equals minus 2 is that then this whole term disappears, and we're left with an equation purely with just a remaining. When we do this, we get two lots of, in this case, minus 2, and then plus 11, and this equals now a, and then in the bracket we have a minus 2 minus 5, which is a minus 7, and then we have the plus 0 term, that is the cancelled term. Therefore, we get that minus 7a is 7, that is the minus 2 times 2 plus the 11, and therefore we have that a equals minus 1. Now we can also have quadratic factors on the denominator. Let's say we had 1 over x squared plus 2x plus 3 multiplied by x minus 1. Here we have a quadratic factor on the denominator. We then guess the form of the decomposition as ax plus b over the quadratic factor x squared plus 2x plus 3, and then plus c over the linear factor x minus 1. Whenever we have a quadratic factor, in the partial fraction decomposition, we guess the form of the numerator as ax plus b. Whenever we have a linear factor in the denominator, we then have a c on its own as our guess for the numerator of the decomposition partial fraction term. Finally, we can have repeated factors on the denominator. Let's say this time we had 1 over x minus 2 all squared, and then a x minus 3. In this case, we guess something slightly different. We guess an a over the plane x minus 2, and then another constant b over an x minus 2, this time all squared, and then a plus c over the linear term x minus 3. So in this case, whenever you have a repeated factor, like in this case the x minus 2 all squared, we guess a constant over the linear version and then another constant over the squared version. In the event that the repeated factor is more than a square, i.e. a cube or a power of 4, and so on, you would keep adding terms corresponding to each power. Let's take a look at some examples. Our first example asks us to use partial fractions to decompose 4x plus 7 over 2x squared minus 3x minus 2. Our first step is to factorise the denominator. The denominator is 2x squared minus 3x minus 2. We can factorise this as x minus 2 multiplied by 2x plus 1. Our second step is to write down the form of the decomposition. Again, our numerator is 4x plus 7, and our denominator is this new factorised form, x minus 2 multiplied by 2x plus 1. And therefore we choose our decomposition guess as a over the first factor, x minus 2, plus b over our second factor, 2x plus 1. Our third step is to multiply up. The left-hand side becomes 4x plus 7, and the right-hand side becomes a multiplied by 2x plus 1, plus b lots of x minus 2. Our fourth step is to substitute in the first suitable x value. If we choose x equals minus a half, this gives us the left hand side as being 4 lots of minus a half plus 7, and this equals, well, the a term completely disappears because then 2x plus 1 is 0. We picked x equals minus a half to give that fact. and therefore the right hand side is just b multiplied by, in this case, minus a half and then minus 2 more. Our fifth step is to determine b. 4 lots of minus a half is minus 2. We add that to the 7 and we get a 5. And the right hand side is minus 5 over 2. And that is multiplied by b. And therefore, b is going to be precisely minus 2. Our sixth step is to substitute in a second suitable x value. Now, we chose x equals minus a half to cancel off the a term. Let's choose x now to cancel off the b term. If we choose x equals 2, then x minus 2 is 0, and that will cancel off the b term. So again, we're going to choose x to be 2. Therefore, we get 4x plus 7, which is 4, and then the x is 2, and we have a plus 7, and the right-hand side is just the a term, so a multiplied by 2x plus 1, which is 2 lots of 2, and then plus 1. Our seventh step is to determine a. The right-hand side is 4 times 2, which is 8, plus 7, which is 15, and this is equal to 5a. And therefore, we have a is equal to 3. Our final step is to write down the decomposition. Originally, we had a over x minus 2 plus b over 2x plus 1, and therefore by substituting in the values of a and b, we have 3 over x minus 2, and then the next term is the b, which is minus 2, divided by the 2x plus 1. Our second example asks us to use partial fractions to decompose 3x squared plus 16x minus 38 over x squared plus 5x minus 13 multiplied by x plus 1. Now notice here that x squared plus 5x minus 13 cannot be easily factorised, and therefore we're going to treat it as a quadratic factor. So our first step is to write down the form of the decomposition, and since we are treating it as a quadratic factor, the form of the decomposition will be, well, obviously we're starting with 3x squared plus 16x minus 38, and this is over the quadratic factor x squared plus 5x minus 13 multiplied by x plus 1. And therefore our numerator is going to be ax plus b, and then over that quadratic factor, x squared plus 5x minus 13, and then we've got a plus another term c over the x plus 1. Our second step is to multiply up. Again, we have 3x squared plus 16x minus 38 as our left-hand side, and then we have as our right-hand side ax and then plus b, and this is multiplied by the x plus 1, and then we have a plus c multiplied by the quadratic factor x squared plus 5x minus 13. Our third step is to substitute in the first suitable x value. Now in this case, the first suitable x values to choose will be x equals minus 1. This is because it gets rid of both a and b, because x plus 1, if x equals minus 1, will be 0. And therefore the whole term with a and b in it will be completely cancelled. So the left-hand side is 3 lots of minus 1 squared plus 16 lots of minus 1 minus 38. And the right-hand side will be 0, the first term, and then c lots of minus 1 squared plus 5 lots of minus 1 minus 13. Our fourth step is to determine c. The right-hand side, when we work it out, comes to minus 51, and the right-hand side comes to minus 17c. And therefore, by dividing, we get c equals 3. Our fifth step is to substitute in 2 other x values. This is because no longer do we have any suitable x values to choose, because we'd have to solve the quadratic equal to 0 to do that, and therefore we can pick just two random x values that we haven't already considered. For example, an easy one is x equals 0, and another easy one in this case, because we haven't already used it, is x equals 1. When we do this, it's very clear that we get a minus 38 for the left-hand side because all the other x terms disappear. That's a minus 38. And the right-hand side is going to be, well, the ax is 0, so that goes away. And we've got a b multiplied by a x plus 1. Well, that's 1 because x is 0, so it's just a b. And then we've got a plus c. Well, c is 3. We know that now. That's quite important to substitute in. Lots of minus 13, because we have x squared plus 5x minus 13, and x is 0, so it's just going to be the minus 13. X equals 1 is another suitable x value because it's very simple to compute. We have 3 plus 16 minus 38, which is precisely minus 19. And then the right-hand side is going to be, let's have a look, we're going to have a plus b because x is 1. So we have a plus the b, and then we have this multiplied by the x plus 1, so that is precisely 2. And then we have a plus, again we have the c outside, which is the 3. And then we have a 1 plus 5 minus 13, which is a minus 7. The sixth step is to determine a and b. On the right-hand side of the first equation, we have a b minus 39, and when we add that across to the left-hand side, we get b equals 1. And for our second equation, now that we have the value of b, we can substitute in and simplify. The left-hand side is still minus 19, but the right-hand side is a 2a by expanding with the 2, and a plus 2b, well that's plus 2, using the value of b, and then a minus 21, from the 3 times minus 7, and therefore when it's all said and done, we have in fact that a equals 0. Our last step is to write down the decomposition. Notice in this case that because a was 0, we needn't have actually guessed the form ax plus b, but that was because in this specific case we were lucky. In general, you should always guess ax plus b whenever you have a quadratic factor. Using the form of the decomposition, we can write it down. We have just the value of b, which is 1, over the quadratic factor, which is, in this case, x squared plus 5x minus 13. And then we have a plus, and we have our c value, which is 3, over our linear factor, which is, in this case, x plus 1. And that is our decomposition of this algebraic fraction. Our third example asks us to use partial fractions to decompose 5x squared plus 14x plus 13 over x plus 2 all squared multiplied by x minus 3. Our first step is to write down the form of the decomposition. Again, we have 5x squared plus 14x plus 13, and this is over the repeated factor x plus 2 all squared multiplied by the linear factor x minus 3. As part of that, we're going to guess that our decomposition is of the form a over the first linear factor plus b over the linear factor squared, and then plus a c over the other linear factor. Our second step is to multiply up. On the left-hand side, we're going to get the numerator of the fraction, and that is 5x squared plus 14x, and then a plus 13. On the right-hand side, we're going to have a multiplied by x plus 2, multiplied by x minus 3, and then a plus b multiplied by just the x minus 3, and then a plus c multiplied by the x plus 2 all squared. Our third step is to substitute in the first suitable value of x. If we use the value x equals 3, this will cancel off the A term and the B term. And therefore, we get, on the left-hand side, 5 lots of 3 squared plus 14 lots of 3 plus 13, and then we've only got the C term remaining. So it's C lots of, in this case, 5 squared. Our fourth step is to determine C. The left-hand side becomes 100, and the right-hand side is 25C, and therefore we have our value of C as being 4. Our fifth step is to substitute in a second suitable x value. We've used x equals 3 already, so if we use x equals minus 2, we will cancel off both the A and the C term and be left with only the B term. So again, we're going to substitute in x equals minus 2, and this will give us 5 lots of minus 2 squared plus 14 lots of minus 2, and then plus 13. And again, we're losing both the A and the C term, so we end up with a B. Because we have an x minus 3, this will become a minus 5. Our sixth step is to determine B. The left-hand side becomes 5, and the right-hand side, of course, is minus 5b. And therefore, we have that B must be minus 1. Our seventh step is to substitute in another x value. Now, we've used both x equals minus 2 and 3, and there are no other suitable x values that we could choose to isolate the A term, which is what we need to find next. So we can pick, for example, x equals 0. This is nice because the left-hand side gets reduced to just 13, and the right-hand side gets reduced to a multiplied by a 2 multiplied by a minus 3, which is a minus 6a. And then we have the middle term, which is a b multiplied by minus 3. Well, b is minus 1 already, so that becomes a plus 3. And then we have our last term, which is a c multiplied by a 2 squared. And since c is 4, this is 4 times 2 squared, which is a plus 16. Our eighth step is to determine the value of a. By putting all the constants on the left-hand side, we get a minus 6, and then this is equal to a minus 6a. And therefore, the value of a is 1. Our ninth step is to write down the decomposition. By the form of the decomposition, we have an a to go first, which is a 1. And this is over just the linear term on its own. And then we have a b, which is minus 1. So we put the minus outside, and we get a 1 up here. And this is over the linear term repeated, so i.e. squared. And then we have our plus c. Well, c is 4, and this is over the other non-repeated linear term, which in this case is x minus 3. And this is the decomposition.
Hey guys, I hope you enjoyed the video. If you are looking for an amazing A-level maths resource, join me today in my series of engaging bite-sized video tutorials. Just click the SnapRevise smiley face, and together, let's make A-level maths a walk in the park.